Welcome to this video on the origins of Indian architecture, focusing on the remarkable innovations of the Indus Valley civilization. Here is our roadmap for today's session. We'll begin by defining what architecture actually means and why India's tradition stands as one of the world's oldest. Next, we'll contextualize where this fits within the broader historical timeline of Indian architecture. Then, we will focus deeply on the Indus Valley civilization, exploring its major urban centers and remarkable achievements. Finally, we'll synthesize these engineering feats to see why these 4,000-year-old ideas still matter directly to civil engineers today. Let's start with our first concept. To begin, let's define architecture. It's the science and art of planning, designing, and constructing physical structures that balance four core requirements: functional, aesthetic, environmental, and cultural. Indian architecture is one of the world's oldest continuous traditions, reflecting the subcontinent's social, religious, and technological evolution over millennia. What makes the Indus Valley civilization so extraordinary is how heavily it prioritized functionality, environmental adaptation, and structural efficiency right from the very start. This pragmatic balance set a foundation for thousands of years of built heritage to come. Looking at the big picture, Indian architecture spans a vast chronology. It stretches from prehistoric rock shelters through the Indus Valley civilization, the Vedic Age, Buddhist rock-cut architecture, intricate Hindu temples, grand Islamic monuments, colonial influences, and into modern Indian design. Today, our lens is fixed strictly on the Indus Valley civilization, dating from roughly 3,300 to 1300 BCE. As the earliest chapter of India's built heritage, the Indus Valley established an urban blueprint that was centuries ahead of its contemporaries in both scale and engineering. The Indus Valley civilization, or the Harappan civilization, flourished along the Indus River basin in present-day India and Pakistan. It represents one of humanity's earliest urban cultures. Unlike many contemporary ancient societies that focused heavily on monumental royal tombs or massive religious temples, the Harappans focused their engineering prowess on civic infrastructure, public health, and standardized urban living. Let's explore the major cities they built, such as Harappa, Mohenjo-daro, Dholavira, Lothal, Kalibangan, and Rakhigarhi, to see how these advanced ideas were actually brought to life. On this map, you can see the geographical spread of the key Harappan urban centers. Major hubs like Harappa and Mohenjo-daro served as vast metropolitan centers, while coastal settlements like Lothal in Gujarat functioned as crucial trade ports. Sites like Dholavira, Kalibangan, and Rakhigarhi demonstrate how consistently these architectural principles were applied across hundreds of miles. Take note of these key geographic markers, as understanding their layout and location provides crucial context for how these connected trade, resource networks, and regional urban planning operated across the entire subcontinent. The defining hallmark of Harappan architecture is scientific town planning. These cities were built on a precise gridiron pattern, where primary roads intersected at clean right angles, dividing the city into orderly rectangular blocks. This deliberate spatial hierarchy segregated residential areas from public and industrial zones. It ensured smooth traffic movement, optimized wind flow for natural cooling, and allowed for systematic city expansion. Long before modern municipal zoning regulations existed, the Indus Valley builders were already executing organized urban planning at a scale never seen before. Every major Harappan city was systematically divided into two functional sectors. On the western side stood the citadel, an elevated platform housing public, administrative, and religious structures like granaries and public baths. Below it lay the lower town, a larger grid-planned sector where everyday citizens lived, worked, and traded. This clear separation represents one of the earliest known forms of functional urban zoning. It separated administrative functions from residential life, ensuring public security, efficient governance, and safety from seasonal floodwaters. The Harappan street system was designed around order and utility. Main thoroughfares were surprisingly wide, typically measuring between 9 and 10 meters, allowing heavy cart traffic and goods movement to pass smoothly. Secondary streets branched off logically from these main arteries to access residential blocks. Crucially, houses did not open directly onto noisy, busy main avenues. Instead, entrances faced quieter side alleys, minimizing noise, dust, and congestion. This thoughtful traffic management highlights a deep understanding of urban livability and pedestrian comfort. Perhaps the greatest engineering marvel of the Harappan world was its underground drainage system. Wastewater from private home bathrooms flowed into small brick channels, which connected to larger covered street drains beneath the roadways. These drains featured gently sloped floors to keep water moving and included periodic inspection chambers for clearing debris. Covered with removable stone slabs, this network kept waste entirely separate from public spaces. It established a standard of public sanitation and hydraulic engineering that remained unmatched globally for thousands of years. Harappan domestic architecture centered around climate control and privacy. Houses were constructed using durable burnt bricks, mud mortar, and timber frames. The layout focused on a central open courtyard, surrounded by private rooms, a kitchen, and a dedicated bathroom. This courtyard layout provided light and natural stack effect ventilation in a warm climate. With solid exterior walls facing the street and private wells inside, these homes offered exceptional comfort and privacy, a design pattern that remains central to South Asian courtyard housing today. Standardization was at the core of Harappan construction. While sun-dried mud bricks, timber, and gypsum mortar were widely used, burnt bricks were the primary structural material. Remarkably, across every Harappan site, spanning thousands of kilometers, bricks were manufactured in a strict, uniform proportion of 1 to 2 to 4 in thickness, width, and length. This strict material standard ensured structural predictability, modular construction, and easy stacking. It stands as one of history's earliest examples of mass-produced, standardized building components. Public spaces in Harappan cities were engineered for utility and community life. The Great Bath at Mohenjo-Daro features fine brick masonry, a layer of natural bitumen waterproofing, and a dedicated drainage outlet, likely built for ritual bathing. Nearby, massive granaries were constructed on raised brick platforms, with subfloor air vents to keep stored grain dry and safe from pests. Multi-pillared assembly halls provided spaces for civic gatherings. Together, these structures reflect an advanced society prioritizing public health, food security, and civic governance. Water management in the Indus Valley was built around reliability and widespread access. Cities relied on a redundant network of deep private wells, public wells, stone reservoirs, and water storage tanks. Unlike other ancient civilizations where clean water was restricted to elite palaces, almost every Harappan residential unit possessed direct access to its own well. This decentralized approach to fresh water, combined with sophisticated storage systems, ensured urban resilience during dry seasons and provided an extraordinary level of personal hygiene for ordinary residents. At the coastal site of Lothal lies one of the world's oldest known artificial dockyards. Harappan engineers constructed a massive, brick-lined basin designed to berth ocean-going vessels. The dockyard featured sluice gates and inlet channels that trapped high-tide waters, maintaining a constant water level so ships could load and unload cargo without grounding during low tides. This masterclass in hydraulic and maritime engineering connected inland trade networks directly to Arabian Sea shipping routes, driving extensive long-distance trade with Mesopotamia. The engineering achievements of the Indus Valley civilization were vast. They mastered sanitation, grid-based urban planning, and complex water management, while constructing durable homes, large granaries, and even maritime infrastructure, like the dockyard at Lothal. Let's review the salient features of Indus Valley architecture. We see scientific grid planning, standardized brick ratios, and right-angled road networks. We see enclosed underground drainage systems, public baths, and raised granaries. Residential architecture emphasized private courtyards, integrated bathrooms, and accessible water sources. Above all, Harappan design was defined by utility, public health, structural longevity, and standardization. These core attributes transformed simple rural settlements into the premier urban centers of the ancient Bronze Age world. Why does this 4,000-year-old legacy still matter to civil engineers today? Because the core challenges of modern urban design, sustainable zoning, effective waste disposal, stormwater management, and material standardization were tackled successfully thousands of years ago in the Indus Valley. Their practical, public health-first approach reminds us that true architectural greatness isn't just about constructing flashy monuments, but about improving the everyday lives of citizens. The Harappan blueprint continues to inspire how we build resilient, functional cities today. Thank you